Hello, everyone. Welcome to today's stream. I'm Wendy. I'm here with Edmar, Maddie, and Ashley on your community team. In today's live stream, we have Devin here today, and we're going to talk about Action Graph, which, as Edmar said during the countdown, is it's visual scripting. I personally like visual scripting. I'm a more visual person, so this is my favorite way to code. But before we get started, we've got a bunch of stuff that we want to announce. So, Edmar,
Yeah,
what do
so
we need to talk about? Yeah.
so we want to remind people we are looking for your content using other tools and Omniverse. So please upload those to the Omniverse gallery. We have a bunch of people scouring through those pretty regularly. We have some great stuff that was posted recently too from the community, so you can look at other people's stuff as well and get inspired. And then on our community page, which is accessible from the Omniverse area. So if you go to omniverse.nvidia.com, click community in the top right, and we have an insider form which you could fill out and start sharing information about what your background is and how you're using Omniverse, what your goals are. If you're open to contracting work, that's also one of the fields, which is amazing. We have a lot of partners right now and people using Omniverse, companies that want to go all in, and they're looking for people with experience that they could hire for contract work or otherwise. So for us to be able to refer those great companies to you, we need to kind of know who you are. So that's a great way to share that information and your interest in that. But even if you're not doing contract work, it's a great way for us to also know who can reach out to if we need some feedback on early access. We have some really cool announcements coming very, very soon on not only Unity but Blender. So keep your eyes on that. And then finally, we have a really cool, I mentioned it briefly, we have another live stream happening this week on Friday. People in the community will recognize this man's name, Omnivore, the original Omnivore, Dave Tyner himself. He is going to be doing something super cool this Friday. So right in line with our Winter Art Challenge, which is currently happening, and you could make a winter scene using Omniverse and share it on Discord. We have a community challenge channel. You can post it there, upload to the gallery, of course. So on Friday, Dave Tyner and his friends, I think he's going to be working with 3 other folks. So 4 creators together are going to be doing a live sync in real time, working on a single scene together. Really taking advantage of Omniverse's ability to have multi-users collaborate in real time. So he's going to show you how that works, how they get it going, and then it's going to be serious. We're going to do it every Friday. It's going to be earlier than this stream usually happens. So it's going to be at 7 a.m. Pacific, for all your early birds on the West Coast, 10 a.m. Eastern on Friday and the next many Fridays, hopefully. So that's going to be a lot of fun. Okay, so those are the main things I wanted to just announce. But Devin, thank you so much for coming. And I'm not joking. This is one of the topics that we have had an extreme amount of excitement for in the community. And I hope you can shed some light on. I have an idea why, but why don't you tell me, why do you think people are excited about it? What is Action Graph? How does it relate to NVIDIA OmniGraph? And then we could take a deeper dive once we get through the basics.
Yeah. Cool. I'm excited to be here too. It's my first stream since starting here. Let me start out. Like I started here in April this year, and I was hired mostly to kind of push on Action Graph as an end user. So Action Graph is right now, it's like a visual scripting language. So like you mentioned, it's going to be really familiar to people maybe who use Unreal's blueprints, or it has a lot of analogs with like Houdini and Substance Designer, all those node-based asset tools. Sometimes you hear in the Omniverse kind of ecosystem, there's this thing called OmniGraph, right? So OmniGraph is kind of like the parent of all of our graphing solutions. And there's all these smart people making all the nodes work really well and be cool. And then we build different graphing systems out of that OmniGraph system. So Action Graph, which is what we're going to be talking about, is like the visual scripting version of a graph system. So what it's good for, is things like interactivity, and you're seeing kind of game-like behavior, video game kind of development overlaps a lot with it. It's really good for kind of maybe if the create app doesn't do natively what you want, you can kind of whip up something that does what you want. Like super obvious, easy example, you can like find every light in your scene and make them black or blue or whatever, right? It's not really like a lot of people sometimes will look at it and think, oh, how do I deform my model, or how do I make a texture with it, right? And it's not that. There's other systems that we have either in development or kind of preview releasey that, like the particles, they're going to use graph systems, but action graph isn't how you make those particles. That's like the particle graph, right? So that's a pretty common thing that I think gets lost with all the graph. Everything's graph, right? Yeah. Should I dive in? Do we have any
Yeah, dive
questions
in.
to start with?
I probably should have let Maddie actually introduce this episode, because this is something he's been heavily involved in the planning for. But Maddie, did I skip over anything? Do you want to go
No,
over
no.
anything more deep?
Sounds
Okay.
sounds good. Let's do it. Everybody
Yeah.
wants to dive in.
Yeah, so I have my screen shared. Let me know when you have it up.
It's up.
Oh, it's up. Okay, cool. Uh-oh. Are you guys still there?
We're here.
Yeah.
Did you
Oh,
hit a
I just heard
button?
I just heard a boop, and I was worried that
Oh.
something weird's happening.
With
I
a
think
cat.
I'm going to turn off my camera because sometimes when I live stream, the camera gets in the way. So I have this scene open because this is what I was working on before the stream, but this is a good little sample of an action graph that we've been building. And this one, what does this one do? Oh, this one controls variance. But you can see like this is all the nodes and they do things, but the whole system is supposed to be like this automated configurator, right? So this is currently what I've been using Action Graph a lot for, is building interactive behavior in the stage. So the way this camera rotates is all done with Action Graphs. And then the way
Cool.
I'm missing the UI for it because I don't have it loaded, but like I'm just going to brute force it here. This is not what we're going to be going through exactly, but this is, so if I switch this to, oh wait, no, that's not what I'm doing. I have a thing where, oh, bear with me here. This is the one I want. I want to change the surface of this table to, I think it's lightwood. Oh, what did I call it? There it is, right? So I just
Ooh.
type this in, and then what this graph does is it just kind of checks things and sets the appropriate values. So since I had to type it, it's not super great. We have a whole UI in progress, but what I was hoping to show you was that the stage reacted to me doing something, and I didn't have to physically like click this mesh and go find a material. All of this is kind of done with logic that the graphs work. And these are all, this is kind of more intermediate advanced level, but these are all layered on top of each other to build out this whole configuration system. So I'm going to turn this off. And so I thought to start with, because we don't have a lot of material on YouTube or Twitch yet about how to use this stuff, I thought we would just walk through some very basic fundamentals, right, of visual scripting and OmniGraph, and point out Action Graph and point out the things it's good at, right?
Perfect.
So the first thing that people are going to run into when they start their thing, if you right click and you do create visual scripting, there's going to be 3 types of graphs, right? So we're not going to talk about push graphs and lazy graphs. We're going to do Action Graph. But push graphs and lazy graphs, I think of as subsets of Action Graph. A push graph is something that constantly updates, and a lazy graph is something that updates when a certain attribute changes. And all of those behaviors can also be done in Action Graph. So the basic way to think about Action Graph is it's all event driven. So I have an empty stage here. If I hit tab, I can look for all my nodes. Also, my nodes would be over here on the left. Oh, the way I got this, I right clicked and hit open graph. There's also, you can go to window, at visual scripting Action Graph to get this window.
Awesome.
Yeah, so like events, right? So a common event is a stage event. So I have my event here, and then these are the things these are conditions, right? So this event will, I use the word trigger. This event will trigger when this condition is met that I pick. So I'm going to pick start play. So basically every time I hit play, this event is going to just announce that I've started, right? So the easiest way to look at this is I'm going to do another node, print text. So right now, right, nothing's happening. It's because these aren't wired. So these gray triangles are execution wires, and this is how the flow of the graph works. So I'm just going to click and drag and connect it. So now when this node runs, the next node down the wire is going to run next, the next frame usually. Event nodes run on frames, but the other nodes that we talk about, they kind of can work between frames if they're fast enough. So I'm going to just, this print text prints to your console. So I'm going to set it to be an error and say, I have printed. So if I go to move my console here. So now nothing's happening, but when I hit play, it says I have printed. And then nothing else happens because this is an event that just runs once. So if I also have I'm going to duplicate these. And I'm going to change this one to stop play. And I have also printed. So now when I hit stop play, this now runs. So that's most basic example of how this works. The other thing I think is really interesting about Omniverse, or Action Graph and Omniverse, is all this stuff I'm doing is live. You notice I didn't save anything, I didn't compile anything. It just worked automatically. So I can also add like a node at the end of this. A second one I have also printed too. And then now when I hit stop play, I get this extra one here. So I don't have to like wait for my scripts to compile or anything like that, which is pretty cool. The execution flow works. I don't know how to describe it. It works kind of in order, reading left to right, but it also works in parallel. So if these were both on the same like start play, these are both start play events, they're both going to run. And I'm going to get all three of them at once. Let me hit it. There we go. But the order they run in isn't necessarily the order that I see them in left to right. It's kind of like whichever one shows up first. They're almost racing at this point. So that's I'll show. We can go through an example of how to set that up.
And that's a scalability feature, right? We can run things in parallel.
Yeah. It's a feature. Exactly. It's really powerful. It lets you do a lot of stuff at once, and your nodes can get really big. I can have another action graph in here that does its own like events for. I'm going to do another stage event of start stage, and we'll print the same thing to the console. And we'll call this one other graph printed. And then if I hit this one to start play, so now if I start, this guy now also prints. You see, he somehow came out first before that one. Maybe if I do this a couple times, he might come out second. There's kind of no way to control it. Well, the way you control it is the flow that you use. So we'll go over that. But exactly right. The concurrence of it is a powerful feature. You just have to know how to use it. So yeah, we're doing left to right. So let's show an example of, I think I had a sample of this made already. Maybe I don't. All right, we'll do one from scratch. It'll be more fun. Am I with everyone with me still?
Yeah.
Haven't bored your brains out.
No, it's
Oh,
great.
definitely not.
Just interject if you have questions while I'm going, right? Because I
So-
might, without seeing your faces, I'm just kind of starting to zone out on what I'm doing here.
There is one question. We got Hong Wang. What's the difference between action graph and push graph?
Okay, so let's talk about that one exactly. A push graph, if I make a push graph in here. So to be fair, I don't use push graphs that much. So if I'm going to do like a write attribute in here. Oh, wait. There's a way to do, well, basically the difference is a push graph will have, it will just process itself all the time.
Can you just throw a print text in there? Would it run on
Yeah,
every frame?
that's probably a good one. Print text.
I've seen pushgraph used in like a particle system, like
There we go.
steam kind of
Yeah.
just coming out. Is that a good example of it too?
I don't know what the particle systems are, but probably like that. But you can see this push graph. I just put a print text. I just made it say print me. And it's just printing nonstop. You can see the second counter moving up, right? So a push graph has this kind of built-in idea of I'm updating myself every frame, and all the wiring that I do in here is just constantly running. So it's always pushing itself up to the stage is how I think of it. Things like a particle system need that because the particles always need to be updated on their their velocity and their colors and all that. The action graphs are different in that they run on command on an event. So this action graph, this print's not going to run until this event triggers itself. But this is the reason I don't really use push graphs is I can already do that in action graph. I have an event called a tick event that I can just make. I'm going to turn my push graph off here. So my tick event is an event that runs every frame. So instead of waiting for this condition of start play to be met, the tick event just constantly shoots itself off like a machine gun. And if I hit play, the tick event's just doing this print string nonstop, just like the push graph was doing. So the way I like to think of it, and to be fair, this might not be like technically correct, but sometimes when I'm working on this stuff, I like to I have a framework of my understanding of it that fits. So a push graph is basically a graph with a built-in invisible tick that you don't see. It'd be the same, like the other push graph we had was just this by itself. And then the action graph version of that is you just wire a tick in, and now it behaves the same as a push graph, essentially.
So it sounds like if you're just starting, it's probably safest to start with action graph. You won't paint yourself into a corner. Yes. You're less likely to paint yourself into a corner.
Correct. And a lazy graph is similar, but it has basically this built-in event that's USD stage, object change. What is it called? This one. So a lazy graph this event will, you can watch an object, like let's add a transform here. If I watch this event fires, let's see, change event. So you're going to see it's going to print whenever anything on this transform changes. So in this sense, I'm moving it. So every time I move it, it fires this event. And then what if I don't move it? What if I change the visibility on it, right? That will also trigger it. So a lazy graph has this kind of idea of I'm watching something built into it. So you generally can do all that same stuff with action graph, and you get access to even more cooler stuff with action graph. So I'd get in the habit of just using action graph personally.
Cool.
But like Ashley said, the particle systems probably use push graphs a lot more. But that's the whole particle graph half of things that I was talking about earlier.
You have counterparts, so you're the action graph guy. Is there like a push graph guy and a lazy graph guy that you're in like a battle with now, and you just started a war with that statement?
We'll see. We'll see if I log into Slack when I'm done. We'll see if I've totally alienated anybody.
You got kicked out of the channel.
Yeah, I know. Lately, like we've been trying to form like a the 5 families council of all the graph people to make sure that the work we're doing in Action Graph overlaps really well with what the particle team wants to do or what the mesh deforming graph people want to do. So it's important that we've been starting to try to do this more so we don't end up building stuff twice or stepping on each other's toes, right?
Yeah, you guys are all part of the same totem pole, not different villages.
Yeah, that's a good way.
I'd personally join Team Lazy.
They're like Harry Potter houses now.
Let me see. What was I doing? I was doing. Let's do more execution flow. So I'm gonna do. I have a video that goes over this, so I'm just gonna replay. So we're gonna do 3 print statements. Doop, boop, and whoop. And we're gonna do it on start play. I'm just gonna wire these. So because of the way I've wired these, they're gonna go in order. So this one first, this one second, this one third. No matter what, they're always gonna be in order. If I duplicate this, so obviously you might see some bugs while we're working. Let's make this over from scratch. I'm using one of our release candidates for a new version. I think I'm a version ahead of what other people would be downloading if they went to our website now.
Ooh, top secret.
Yeah, so there might be, I don't think there's much in here that's going to be different, but you might just see a few bugs while we're hammering things out. Start play.
When you add new updates, what generally do they kind of focus on?
Let's see.
What's the next one?
The latest, I think right now we're focusing on like usability improvements. So like the way we do some of our wiring, we have some improvements for that coming in down the pipe. Cool. We're trying to kind of fix some of those quality of life issues.
Is one of them to select the little noodle and then just click delete and not have to right click?
We got an even better one.
What is it?
We have a design where what we want to do is you want to stick a little dot on the noodle, and then you can select that dot and either delete it, or you can select that dot and move it around so to reroute.
Ooh.
And then if you double click the dot, it will be a debug window that shows you the value of that wire.
Oh, nice.
Wow.
Very cool.
I wouldn't even imagine to ask for that kind of feature. So, yay.
Yeah, it'll be cool because that'll help. Because right now we have to use all these prints to debug. There's no way to kind of sense what's happening. So having little numbers on all my noodles is going to go a long way to making it easier to try to find out when I broke something. Yeah, so if I hit play now, let me clear this. See, doop, boop, and whoop all went in order, but doopity got stuck at the end because he's basically racing to see which one of these guys go through. So if I stick him in the chain right here, now he'll go in the middle, right there. Another cool feature of Action Graph is we can do fanning out, which a lot of graph tools don't do. So I can take one input like this, and I can go to 3 destinations like that. So after this guy runs, these 3 will all run simultaneously. So it's going to be the same thing. It's going to be whichever one wins. So let's see who wins. Looks like Doopity won. So that's this one. And then Whoop was second and Boop was third. So the execution at this point is like, after this, do these 3, but there's no control over what order those 3 go in. And same way, if I start coming out this way and building out more horizontally, it's going to do this one, and then it'll start it'll pick back up on an order, but the order of if these were all, if we had another chain below it, all these chains will start running simultaneously, which is powerful, but can be tricky sometimes trying to keep track of the order you want things to go in.
I have a question for you really quick. I saw in one of your graphs that you were able to like put a little background to like group those together. Can you show how you did that?
I can. So it's a new node called backdrop. I don't know when it came in. I think it might be in the public version right now. So
yeah, it is. I just didn't know how to do it.
Oh yeah, so it's just backdrop. So then you double click here and you can type out, this is my description.
I totally missed the notes feature.
So cool.
And then when you click off of it, it'll store your description. So then if I move this guy over these boxes, now they're attached to my
gosh.
backdrop here.
Nice.
Drag and drop.
I can change the scale of it. So, you'll notice when I type backdrop, it says beta. So there's still some rough edges on it. Like I can't like marquee select just the things inside it. So you kind of have to manually click them and then deselect it you can only move one at a time out, but there's workarounds. The thing I like to do is I just squeeze my backdrop really small when I need to move it away from my nodes like that. And you can also change the color, but right now the color, that got better. It used to like lag a lot. Yeah.
Very cool.
Yeah.
We got a few questions from one of our great users out there, Zia. Can noodles be straight lined instead of curves?
Yes, there is a way to do that, but I don't know where the button is. But most of my coworkers do the straight lines, but I don't. It might be. Oh, I know I've seen it. I just don't know where the button to do it is. Someone is probably watching this at work and yelling at the screen.
Someone who works for Pushgraph.
Yeah.
You should post in the chat. We'll get back to you later on that, Zia. The other question he's got is, can you have a graph that contains other graphs? So there could be nodes that are visually collapsed, like putting folders in a folder or layers of layers in Photoshop.
Yeah, so that is a feature we're actively developing now. We're calling them compound graphs, and that lets you build complex behavior and reuse it. So right now, there is no support for that. There's no way to, say, take these nodes and collapse them down and be able to call this collection of nodes later. There's a pretty good design for it. We're working through the tricky bits of basically where to store those, because the way a lot of Omniverse works is it's just kind of stuff on your stage, and we're trying a way to store them like the same way I would store this desk asset here. How's the best way for me to store a graph so that I could drop it in somewhere and use it again? But not drop it in my stage, right? Drop it in my actual graph flow. So that's a big feature for 105. And I'm not really sure what our release date for that one is, but hopefully soon, because that's definitely a thing that cramps what we work on a lot. Having that will introduce a lot more I like to think of it as kind of standard programming practices of breaking down the logic you want in reusable chunks, so you don't always have to keep rewriting the same thing.
Yeah.
Yeah.
You can you have action graphs call other action graphs, or do you have to?
Yeah, we can talk about that. The one way I'll point this out. The best way that we do it now, and this is how, let's say I have this camera system that I built, right? And so I've taken over the viewport, and now I have like an orbit camera, and all the logic for it is right here. And I don't want, so the way I built this to be reusable is this is all stored in a file, this camera basic orbit, right? So now I can go to a new file, and I can just drop him in here, and all of his logic is there with him. And then if let's see if I built this, if I trigger it, there he goes. Now he's turned on, and then all this logic for orbiting would work. I have to do a few other things to make it work. But the idea is that just like any other prim in OmniGraph, any other prim in Omniverse, the action graph is just another prim. It's just like dragging a cube somewhere. So I also have graphs like this one that I showed at the beginning. You'll notice this scene is empty. There's nothing in it. The only thing in it is a graph node. And this graph node does all the stuff I want it to do. And it has a couple variables in it. So when I have a new stage, I can drag this one in here, and it's in my stage, and all the graph nodes are there. And the variable, one of the variables I use is like how to attach it to something. So that's kind of the current way, the best way we have to reuse your graphs, is you just kind of save them as their own little isolated files. Let's see, maybe we can whip one up really quick.
Seems like such a great way to be like, okay, this is why USD is so important, because in one of them you had assets, like not just like the logic, but you brought in the asset connected to the logic. Like, yep. I can't imagine being able to do that in any other program that doesn't use USD without having to import multiple different files together.
Yeah, it's really nice as you start to use Omniverse and you get used to the USD kind of hierarchy. Some of this stuff starts to click. I want to show root. So I'm gonna make a really quick action graph here. So I'm just gonna make it my default prim, which is like a USD concept of this is the global root of this file. And then when I edit it, let's just do keyboard event, and we'll do the letter J. I'm going to turn off simulate on play, so this will work all the time. So I'm going to do, when I press the J key, I'm going to print out this variable. Printed string, and the default will be hello Omniverse. So if I print this, so now you'll see same thing. I'm going to print to my console, which I've down here. So now when I hit the J key, it says hello Omniverse, right? So if I save this whole file, call it test reference, and I make a whole new stage, I can then go, where did I save that? Samples? Right here. So I can drop him in here, and then if my console, the J key, it's going to work, right? It says hello Omniverse.
Cool. That's awesome.
So I can now place a couple of these. So I can duplicate it, and then this one, I'm going to change the variable that I made originally, right? Because it's right here. I'm going to say this, let's say hello Jensen. And this one can say hello NVIDIA. Whoops. So now they all still respond to the J key. So now when I hit the J key, if I did it right, there we go. Now we got all three of them saying different things.
Nice.
And this is a great like little sampler of the USD power. Oh, hold on. My vacuum is getting close. Did you guys hear it? It was like getting close.
No,
they want to be on the stream.
Does your cat ride your vacuum around?
No, they just ignore it. I don't know where my cats are. So like I could save this file so that this is all working. I might as well do this. Saved graphs. So since these are references, I can just go open this original one and go change something in here. Like I want it to say, I don't know, what should we do? We should do, I don't know, we'll just do another print of some kind. And then this print can just be, goodbye. So I'm going to save this file. And then if I just go back to my other file, this one, nope, not that one, this one. Now, if I hit the J key, you see now they all say goodbye at the end, right? So I have a single source of like truth for this graph, and I'm just reusing it elsewhere. So that's close to what the question was about, but it's not completely there. So the big difference that I think that question was getting at was I want to be able to do that inside my graph, and that's the part we're still working towards.
Gotcha.
But soon, that was like the big, we've been hiring a lot of people like me, right, who used to be game developers and people who used to work in film industry and people who used to work on 3D software. And we've all been pushing these like concepts of like, oh yeah, well, I need a way to save graphs, or I need a way to change the time on my material so I can do animated materials. And we're just finding all these little pieces that an average kind of tech user, in my case, would want, and writing them on the board, putting them on the to-do list, and going through it. And I think
when you're working, do you ever use the visual scripting layout?
Oh, I usually do, but I think for streams sometimes it's nicer to have it nice and wide. But let's call it out. There's a visual scripting layout here, which is nice because it gives me more space for my graph here. Oh, I lost my graphs. Let me turn this off.
Yeah, I was playing with it back and forth between like the regular layout and the visual scripting layout in my last stream. So I was just seeing what the expert thinks on it.
I actually made my own layout. I do, let's see, I do one that's close to this layout, but I put my content browser at the bottom of my graph view so I can do this. Here, let's just build it. So I get rid of the timeline because I usually don't care about that. When I'm making action graphs, I'll often be clicking on things, and the graphs are usually really long, right? So I'll usually put the property node right here, and then I'll stick my console below my stage. And then I just kind of do this because I usually, in this mode, I don't really care about what's on my, how fancy my viewport looks. So this is kind of like my version of the visual scripting layout.
I like this a lot.
Yeah.
Wait, and then I put content. I forgot content.
Might steal that.
Here. Yeah, like that.
Don't be surprised if you look at a stream that I do and my screen looks similar.
Just drop the layout file in the chat.
Yeah, but the nice thing is, right, I can save this layout somewhere and then just load it whenever I want, which is what I did. So I customized it for how I like to work.
That's really cool.
Yeah.
We got a question from a first-time viewer. So welcome, by the way. Do the nodes have a text representation so it's possible to modify or learn from their implementation? Something like VEX code in the attribute wrangle node in Houdini.
Oh, so I guess no, we don't do any kind of VEX kind of stuff. The closest thing you'll find to that is similar to Houdini and VEX stuff. Like, I'm going to click, let's add a sphere here. Mesh sphere. So my sphere is just a prim in my stage here, and it's a mesh type, And because it's a mesh type, it knows that it should have all these attributes and what they do, the type knows what to do with it. But all these attributes are just paths. So this attribute is called normals, and you can see in the parentheses the format of the data, which we can go over next. So like I can right click this and do copy path. And then let's say I have a USB change event. Instead of trying to like select a prim, like this sphere, as the thing I wish to watch, I can just directly type in the attribute I want to watch instead. So now this event will only run when that specific attribute is changed, which is the normal attribute. I'm going to turn this off too. So if I click on my sphere and I picked a terrible idea attribute to check because I can't change that one. Let's do.
I saw that coming.
Let's change this. Do orientation. So now if I click my sphere and change this orientation, you'll see my console said, hey. But it won't change. It won't fire if I if I move anything, if I change any other property. So that's probably the closest overlap I can think of to Houdini's Vex system and their kind of attribute system with slashes and properties and all that. Is
okay.
All of these things are just properties, and the whenever you need to know what it is, you can just mouse over it. So sometimes you might have a right prim attribute. This is one we use a lot. And if you want to, so you can write a direct relationship to this sphere. So this thing always writes to the sphere, and then I get a drop down of everything that's on the sphere. But sometimes I don't know what I want to write to yet. So I don't have a drop down because it doesn't know what to pick. And that's what this path thing would do. So in those situations, you're going to have to know your attribute name. So I know that the name for the rotation is xform op rotate xyz. Right, so it's not exactly Vex-like, but close-ish, where I'm typing in paths and attributes and stuff. But I think generally we're trying to make something a little more straightforward and less technical and typey. I feel like every time I'm typing something that we need to improve the UI so I don't have to type it.
Gotcha. Okay. Well, thank you. We have another question regarding other interfaces like controllers. Do we have nodes for like the Xbox?
We do.
Controller?
There's a gamepad state and a gamepad input. I don't have an Xbox controller plugged in right now. I believe someone showed me this morning. If you just plug your Xbox pad in, the viewport actually you can just fly around in it. I think that just worked out of the box, but maybe he did something to turn that on. So all of our inputs, so we have mouse, keyboard, and gamepad.
Do we have like a VR headset or anything like that? For
I
the
think
VR
we have
controllers?
I know we have a separate VR build of this program.
Okay.
And I know someone was working on it recently. And I got the sense that there were VR specific controls, or maybe he was using the gamepad inputs and they were just, I don't know, the face button is the button on your little handset for your VR controller. So I guess the answer is I know that we have a system that works with VR interfaces, but I don't know what's different compared to what I have right here on screen. But it probably works really similar. It's probably an event that has, if there's a unique one. So if I'm on a Xbox controller, I have a input for like when I push the buttons, when I move my stick up or down, and then the read states will report back the values of those. So if this is the x-axis, it'll give you a value that's, you can see if you mouse over it, it'll tell you what it does. Fortunately, I don't have a gamepad, so I can't show you. Oh, you know what? I can show you with my mouse, though. So same thing, we'll do print text. And then I'm going to read my mouse state. And then I'm going to do the coordinates. Why not? So because my coordinates are a number, I have to convert it to a string, which is basically just a fancy way to say words. So I just converted these numbers into words. And then if I turn that off, and my mouse state is my mouse coordinates. Did I do it right? Oh, I'm printing to the wrong spot. There we go. So you can see as I move my mouse, it's reporting back the position of the mouse. You can see it down here. So if this were a gamepad, right, it would be 0, 0. Where's my 0? Down here? No, it's up here. It would be like 0, 0 until I move it up, and then it would slowly move up to 1 and then stop again when I let go.
I think this might be a good opportunity to talk about the data flow with this example.
Yeah, let's do that. So let me turn this off. I don't like all this spam. So we started out talking about execution flow, but data flow is what all these little colored pins are. So the execution flow is like, this is the thing I wish to do, the command I'm running. And then all these little colored inputs are the data that informs what that command's doing. So for the print text one, which is what we've been using, the text that I'm typing here, I can also pass through dynamically what I want that text to be. So this text, in this case, I read the mouse state. So in a general sense, the way I like to think about it is when this node is triggered, it looks to see what you have connected. It goes, oh, I need to go find what text Devin wants me to print. So it's going to go backwards down this line. And it's just going to kind of keep going backwards until it hits a dead end. And then it's going to execute. It's not literally doing this. This is just how I like to think about it to make sense of it when I'm showing people how it works. So it's going to go all the way back, find the last thing, and then it's going to run all this logic this way, right, left to right, to fill out what this text should be. So let's do, I'm going to do, instead of our variables, we're going to do constant string. So we have constant nodes, and that's how you just do a number, like a constant value. Like if I want a number that's always 7, right, I would do that. So there's a constant string. So I want this to say hello, and then it would go in there. So when on tick, it's just going to say hello all the time, right? I'm going to leave this running actually, because this is kind of cool. Another example of this is simulating all the time. I'm not compiling or anything. So I want to make this maybe more complicated. So I'm going to do append. And then
how are you doing those quick searches?
Oh, yeah. So hit tab.
Ah, easy.
So hit the tab key and then just start typing what you want. We have ways that we would like to improve this, because sometimes you get stuff that's really not really what you're looking for, or stuff that's maybe has the word append in it, but has nothing to do with appending. The node list here also has the same kind of feature, but tab is the big, awesome one. We also have ideas to maybe have that pop up when I drag out. Like if I let go, that screen should pop up.
That would be nice.
Yeah. So append is like the fancy word for combining two strings together. Hello, my friend. So I'm going to combine, which one's suffix? That's last, right? Yeah. I'm going to combine those together and rewire it. So now it says hello, my friend, right? Because I've changed the things that contribute to what this input should be. And these data chains can get really big. And that's kind of where all the what I would call the interactivity and the dynamic logic of this can work from. So let's say we can also make, here, we'll do it like this. We're going to add a variable. So none of this is really like useful in a sense of like, I'm going to build a cool system that actually does this, but it's really good examples of how all these bits work together. So I'm going to, whoops, I have a text variable. So if I mouse over it, I can read or write. So I'm going to write to it. And then I'm going to write the value of, what should we write? I'll do 2 of these. Then I'm going to read it over here. So now you see my, whoop, I did the wrong. I want this one there, that one there. This one will say hello. So now it's just saying hello, and it's trying to add this string, which is empty right now. So I'm going to switch it to on my mouse button. When I left click, it's going to say, hello, my friend. And when I let go of it, it's going to say, hello, my enemy. So you can't see me or hear me clicking, but you can see as I'm clicking here, the variable's changing.
Nice.
So this part of the graph is responding to these mouse events, and it's just setting this variable to be 2 different things depending on what I last did, whether I've pressed it or released it. And then way down here, I'm reading this variable, which at any moment could be changing based off whatever's happening up here. And I'm combining it with this hello, and then I'm dynamically building the thing that plugs into here.
I will say it's very interesting to watch you work, and I think that's this, like, what's so fun about visual scripting. You can just sit there and relax while someone else does all of the hard work.
I like it because it feels very visceral, like I'm
Yeah.
playing with little miniatures almost. There's like all these little things I can poke around, and honestly, it's kind of weirdly fun to sit here and kind of tidy it up and make sure it's like nice and clean and easy for someone to read. I've seen a lot of scary nodes where, like, you know, these things are stretched around like this and you have no idea what's happening.
I feel personally attacked.
I'm about to say, you know who the artist is and who isn't.
Oh, well, we'll get you tightened up on that. We'll do some lessons, all right? Let's see, what we got, 5 minutes, right?
Yeah.
That's true. Yeah, and
Man, that went quick.
It does go quick. I did want to ask you, what about performance considerations, right? Because this is obviously not going to be as high performance, I'm assuming, if you were coding it.
Yeah, it's going to run slower than if you did it natively in C or Python, probably. Oh, speaking of which, there's actually a Python script. So if you know Python, you can just add your own Python code in here. I don't know Python, so I don't use this, but smarter people than me do, and I ask them what to do, and then they give me stuff to paste in here.
Maddie knows Python.
Yeah, there you go. You're my new hookup.
Yeah, that's why I don't mess with the nodes. I just write it in Python. But
yeah,
the nodes is supposed to be faster, as what
is it really?
I heard. Yeah,
oh,
Python's slow.
Okay. Yeah, well, there we go.
All the time.
The nodes are faster. So far, I haven't hit any really bad performance problems other than ones that are kind of built into the node I'm using. So we have a raycast node, and you use this to like shoot a laser beam from your camera to the scene and then find what it hit. So sometimes this can get expensive if you run it a lot or if you have a really high polygon mesh or something. So that's not really the graph's fault. It's just the way you're using it. Like, it's kind of my fault because I authored it poorly. You can get into probably trouble with like these tick events where it's trying to do something every frame. Like if I'm trying to do a lot of really, really complex math every frame, it's going to slow down a little bit.
Mm-hmm.
But the type of stuff you do in your graph usually isn't super complex, at least stuff I have done so far. But there's ways to manage that. So you, like if you had to do that really hard math, you would have some other part of your graph do it on command. Actually, we can squeeze this last one in. There's these things called events, custom events. So this is a great way to clean your graph up and have parts of it run on command. So, and these kind of work based on typing it out. So I'm going to say my event is the name of the custom event. And then I'm going to type it in here also. So let's see, we'll just move it like this. So now my tick is going to send this custom event, which is my event, which is basically like this node shouting into my stage, hey, everybody, my event wants you to go. And then everybody who has like a listener, which is this guy, set up as my event is going to respond to it. So if I just turn that off, so now the same thing's happening, but my tick is actually running my event instead. So this event could have been instead, like if I put it over here. So now my event runs after my mouse clicking. So it's not running on tick anymore. So it's kind of doing the same stuff. I've just offloaded where it runs. So if I had a lot of, for example, super complicated math that would bog my system down on tick, I would do an event that runs it when I need it and then store it somewhere so that my tick can use it as needed and not have to calculate it every frame. That's usually the performance problems that I run into, is like I've just overcomplicated something. And then I think it's not really a performance issue, but sometimes when you get really, really big graphs, this graph editor runs a little slow, especially to load it up and to add new nodes to it. But I mean, we're talking hundreds of nodes. I think here, I'll show you like the nightmare nodes that I built.
Yes, I'm going to
for
see
the
those.
Remap configurator. Where is it? Assets, UI. Let's load this up.
So Devin, we need to get you on here for like 3 more live streams before the end of the year.
One a week.
You're always welcome.
We'll sign you up.
Oh.
So
Look
this
at that.
graph, this part here is all the variables I made. This is a bad graph. Like, don't look at this and go, man, this dude knows what he's doing. This one was us really trying to push what we could to the maximum like amount, and then we found a lot of things that just were not great to work with. So this was like our learning lesson of, ooh, this sucks. Let's fix this. So this node, look how big this graph is, right? It just goes on everywhere.
Holy cow.
And it's a little slow to navigate. You see it's a little laggy. If I added like a backdrop in here, it's going to take, a little bit of time.
Oh my goodness, it has to process.
Yeah. So performance-wise, this is usually what I run into before anything else. It's just so much graph nodes, it just becomes a slog. So this is when I've started, earlier in the stream, I showed how we can separate the graphs out and then just reuse them in stages. I've started doing that more to kind of make my graphs a little more easier to manage and easier to follow along with, and also easier to split work up with. So if I have, if let's say this part of the graph was separate, someone else could work on this while I worked on the parts up here, and we could share our work. So
That's awesome.
Nice.
Yeah. Yeah, I mean, I had a lot more to go through, but maybe next stream.
Oh yeah,
Tomorrow.
we already have people in the chat that are ready. Twin Snake says, "Yes, I can watch this guy all day."
Where we go? Here, camera.
I gotta say, you should do an ASMR live stream on Action Graph, just Action Graph work, and just use your smooth talking voice as you're working on some.
Doing swoop, dupe, and swoop.
You always think your own voice is weird, so.
Nah, you've got a radio voice. You're great.
That's what people told me. Yeah. I made a video yesterday and I was watching it and it put me to sleep. I was like, I was victim of my own magic. Just nodded off.
So you mentioned your experience with game dev before. Can you share any of the games you worked on in case anyone has played them?
Yeah, so I used to work at a company called Sony Online Entertainment, and they most famous for making
Heard of them.
EverQuest.
EverQuest. Wow.
And I worked there for a long time, but ironically, I never worked on EverQuest. I worked on a lot of all their other games, but not really EverQuest. So that's kind of where
I was a huge EverQuest and EverQuest Online Adventures. Did you do that one too?
No, I worked
on that one.
No, my big one was Star Wars Galaxies, which was back in
gosh.
Oh yeah, I've heard of that game.
99, 2001, something like that.
That's awesome.
But yeah, most of my career was online gaming like that, and then the last, I don't know, 8 years or so, it's been shifting. It started shifting to more graph-based work and procedural workflows. And once, probably the last 4 or 6 years, I got really into visual scripting. I was like, this is cool. I don't have to make rocks all day. I can do really fun kind of pseudo coding, which seems to work for my brain. So yeah,
yeah.
it's really exciting to work here, right? To be able to kind of build this up and push it in ways that I was always before just handed the system here, work with this. Now I can build it up. It'll be fun.
That's awesome. Speaking of super coding, Ashley, I'm going to put you on the spot. Why don't you tell us what we have planned for next Wednesday's live stream?
Oh my goodness. Yeah. So next Wednesday's live stream, we have our winter art challenge. Is that the correct way to say it? And my lovely coworker, Jen, she's also a connection evangelist and extensions expert. She's going to be showing off the extension she made, which is a winter light show in Omniverse. And I'm inviting the professor of some interns that I helped coach for 10 weeks. And he's going to show off an extension they made using Replicator.
Oh, that is
awesome.
sweet.
And Tyner will also be there, Omnivore, showing off the scene he's working on this Friday's live stream.
This Friday, yeah.
So he will show that off on next Wednesday's live stream also. So if you miss him working on it on Friday, he's going to show it off again next Wednesday on the regular stream. So that's going to be fun. We're going to just, maybe we can get Wendy to put together a couple little holiday-related trivia questions. I don't know.
We could play a game or two, you know.
That would be fun.
I also have a top secret announcement for developers on that stream. I can't say anything yet, so they have to log in next week.
Well, don't tell me because I will spill it. All right. Well, that is
I
awesome.
Know.
I know. That's
developers
great.
only.
Oh, wow.
I'm just kidding. It's open. It'll be open for anybody that wants to
man.
try their hand at it. So if you're interested, it will be announced on Wednesday, December 14th.
Awesome.
That's
will
awesome.
be there.
All right. We will all tune in. Well, we have to tune in. We're going to be hosting it. So we'll definitely be there. Devin, thank you so much. Maddie, thank you so much for helping put this awesome stream together. Ashley, thanks for joining. Wendy, thanks for doing your awesome Queen of the Stream responsibilities. Devin, do you have a couple minutes to jump on Discord and see if we've got any of the viewers who want to jump on and listen to your awesome voice for a few more minutes, ask some questions?
Yeah.
Awesome.
All right. So we're going to say bye on the Twitch YouTube stream, but we're still going to be live on our Discord server. So discord.gg/NVIDIA Omniverse. Go to the community room where Ashley just left a stream right before this stream. That's where we hang out, and you're free to turn on your webcam or turn on your mic and ask questions and chat with us. We'll see you there in 1 minute. Thanks everybody until Friday's Tyner stream and then next week Wednesday. So thanks for joining.
We'll see you guys soon.
Bye.
Bye.